water tanks are pretty cheap batteries. Can you explain that idea in more practical terms and maybe sharing these scenarios that you can about how they can make the grid more reliable and kind of lower costs for the utilities?
Water systems have lots of tankage already, typically, and water systems can absorb. If there's extra energy on the grid that needs to be used someplace, we could pump water during the day if that's when we want it to be pumped and store it. Or lots of grid utilities, they want to unload the grid during maybe the late afternoon. And so we don't pump during that time, and we'll pump at night when the power, there's more power available. So either way, however it works, however the grid wants the water utility to respond, they can. And if they can't, another tank might allow them to respond better.
What if one of the most overlooked energy assets in your community isn't a power plant at all, but a water tank? As the energy transition accelerates, water and wastewater facilities are quietly becoming key players in grid reliability, cost control, and sustainability. Yet, many engineers still see them as fixed, energy-hungry systems instead of flexible infrastructure with untapped potential. In this episode, I'm joined by Layne McWilliams, licensed professional engineer, principal consultant, and treatment group lead at Parametrics. With more than 30 years in water and wastewater infrastructure, and the last 15 focused on reducing the energy footprint of treatment systems, Layne brings deep experience from design through operations and optimization. We'll talk about how treatment plants can act like cheap batteries, which long-held treatment rules of thumb deserve a second look, and how engineers can realistically lead energy and process change in a risk-averse industry. If you design, manage, or influence infrastructure projects, this conversation will challenge how you think about energy, operations, and your role as an engineer. You'll walk away with practical ways to improve performance, reduce costs, and deliver more resilient systems. Not someday, but on the project sitting on your desk right now. And Layne also gives some project management advice and leadership advice in our hot seat at the end. I'm your host, Anthony Pisano, and this is the Civil Engineering Podcast, the industry's leading show for civil engineering professionals, ranked as the #1 civil engineering podcast by FeedSpot. Let's dive in. Layne, welcome to the Civil Engineering Podcast.
Yeah, thank you. Great to be here.
Excited to have you. So, Layne, to kind of get us started, maybe you could tell our audience a little bit about yourself and how you got started in the water and wastewater side of things.
Well, I always tell my kids, be careful what your first job is. I went to college to I was going to be a motorcycle mechanic on a race team. And
Wow.
my first summer job was my first real engineering job was at Parametrics, actually, for a summer intern. And turns out they were doing water and wastewater work. And that's just kind of how it started. So a lot of people I talk to in the plants sort of fall into the wastewater space, right? They either construction slows down or something. So it seems to be pretty common. You just sort of end up here accidentally. And, but I love it. I've been in it for over 30 years now. So it's been good.
Wow, that's great. So I'm going to jump right in here. One of the phrases that we might hear in the industry today is that water tanks are pretty cheap batteries. Can you explain that idea in more practical terms and maybe sharing these scenarios that you can about how they can make the grid more reliable and kind of lower costs for the utilities?
Yeah. So, first of all, putting an equalization tank in front of a wastewater plant is what every operator dreams of. And any operator that has an equalization tank in front of his plant is happy to have it. The plants just run better if you can equalize the flow, right? Wastewater has a diurnal curve to it. So you have the flows come up during the day and then they fall off at night. And if we can put an EQ tank in front of it, then you can equalize that and sort of level those, shave the peaks and fill in the valleys. So on a wastewater side, how does that help the grid? Well, the shortage of power around the grid really is around 200 hours a year where they just sort of don't have enough power. So if we can unload the wastewater plant by using an equalization tank, right, that allows us to, you store the water up front and then you treat it later. That brings the energy level of the plant down, or load shifts it to the right time of day, to a more favorable time of day, and that allows that to happen. On the water side, drinking water, what I mean by batteries tanks are a cheap battery there is that water systems have lots of tankage already, typically, and water systems can absorb. If there's extra energy on the grid that needs to be used someplace, we could pump water during the day if that's when we want it to be pumped, and store it. Or in lots of grid utilities, there's they want to unload the grid during maybe the late afternoon, and so we don't pump during that time, and we'll pump at night when the power, there's more power available. So either way, however it works, however the grid wants the water utility to respond, they can.
Hmm.
And if they can't, another tank might allow them to respond better. So we spend a
Interesting.
lot of money, right? There's a lot of money going into grid storage batteries now. Big, renewables plus battery storage. And I'm just throwing it out there that we know how to build tanks. They're relatively cheap. It makes the systems run better as well. So there's benefits on both sides. So it might just be an opportunity for us to think a little bit differently about grid management in the context of water and wastewater utilities, because every city's got them.
Yeah, that's interesting because I did most of my civil engineering work in the stormwater world, and what you're describing is somewhat similar to me in terms of like you store your water in a detention basin with a weir and you let it out over time, right?
Mm-hmm.
As
Yep,
opposed to letting it all off the site when it rains and you flood the whole
exactly.
town, right?
Right.
So
That's right.
sounds like a similar type of thing where you're taking something with a peak and you're trying to more distribute it over time.
Yep. Yeah, exactly. And with on water systems, right? They need storage anyway, right? Because you got to have water stored in case you lose power, or for fire flows and all that stuff. So there's regulated amounts of water that you need to store, and then there's operating volume, right? That moves up and down. And one of the things we do in energy efficiency programs is sort of help them optimize that working volume. But having more tanks, if they're short on that and they feel uncomfortable about that, more tanks allows them to have more flexibility. And tanks, I know they're expensive, but they're relatively inexpensive, um, to some of these grid storage schemes that are out there now for
Interesting.
batteries.
So, Lane, another term that we hear thrown around these days is energy transition.
Mm-hmm.
What talk about what that means for water and wastewater utilities. What it really means. I think there's some noise and some hype around it, but what does that mean?
Yeah. Well, I guess my version of energy transition is we'll stop burning rocks eventually. And because we're not doing that, we're going to use a lot more renewables and intermittent sources of energy, right? That maybe aren't baseload, maybe aren't available all the time. And along with that comes then more distributed resources. So fewer big central plants and more energy being generated around the grid. From a water and wastewater perspective, let's talk about wastewater first. You know, there's kind of been an emerging boom in biogas utilization, right? So wastewater plants traditionally use biogas for their boilers to heat up the sludge in the digesters to make that process work. Almost all of them have excess biogas that traditionally was just flared. They started using that as cogen. So now some plants use that to generate electricity. Maybe a more valuable use of it in some places is to convert that biogas into renewable natural gas. So you clean it up and then it becomes a natural gas. It's just methane. And you put that back into the grid, to the utility gas network, right? And there's economic reasons to do that with environmental credits and RINs and things like that. Um, Maybe not as much in the current, like over the current administration, but eventually, that I think that stuff's going to come. The economics come back to make that work. The second part of that is, like I said, distributed renewables. I shouldn't say most, a lot of facilities have extra ground around them to
Hmm.
grow. And that extra ground can be used for, decent sized solar farms, that kind of thing. So that's part of that energy transition as well. And then the tanks that we were just talking about, right? Water and wastewater systems can now play in the energy space through demand response, which is load shedding, right? So you get a phone call that says, "Hey, we need you to unload the plant," and you remove so many kW, you get a nice fat check for doing that. And most facilities can unload for 4 hours at a time. The bugs are happy; they do their thing. So there's lots of places where you can just unload the plant a little bit over a short amount of time, and the utilities are happy to pay you. The electric utilities are happy to pay you for that. So that's part of that transition as well, right? Load shedding or load shifting. And like we said, sometimes if there's lots of extra renewables and you're curtailing power because you can't use it, if all the water systems were suddenly said, hey, we'd really like you to put some water up in your tanks, can you do that? They would do that. They do that in a heartbeat. They just got to communicate.
Yeah, interesting, interesting. And the reason that we wanted to have Layne come on and talk through some of these things today is because we do run some kind of project management events in the industry. And I noticed in the last couple of events, a lot of the chatter is about water and energy, right? You have even some of these, we haven't even talked about it here, but like some of these data centers, right, for AI
Oh yeah.
that were requiring water, and what they need to run these data centers is creating a lot of projects and sometimes challenges and things to talk about. So,
Yeah.
these are topics right now that are really, really relevant throughout the industry.
Yep. Yeah. And that, it's kind of, I think the electric industry is really interesting right now. For 30 years, loads were kind of like flat or even decreasing, right? We were offshoring a lot of our manufacturing, and sort of the big loads went overseas, and yes, population is growing, but not very quickly, and things get more efficient. And now in the last few years, you've just had, every time they reassess their needs for the future, that just gets steeper and steeper. And a lot of that's driven by the data centers, EVs, right? Electric vehicles, the electrification of everything, right? What we're trying to get to.
Right.
So it's interesting that the old staid electric industry, which was kind of boring, frankly, is probably the most dynamic space now, industrially in the country, right? Just all kinds of cool stuff happening there. So, um, and at the same time, from my world, water and wastewater people ought to be playing with those folks. They can help, right? The
Yeah.
water and wastewater people can help manage
That's
that
what it
new load.
sounds like. It sounds like there's very similar things to what you've already described for us today in terms of the amount of energy required,
Mm-hmm.
right?
Yep.
For things of that nature. So, Layne, I know you work with a lot of utilities. If a utility wants to reduce its energy footprint without kind of compromising compliance, which of course they deal with as
Yeah.
part of business practices, what are some of the unit processes or components that you would typically look at um, to try to help them with that?
So when we work with, let's take a wastewater plant for start.
Sure.
Um, I always, for an operator, messing around with their process for energy reasons is kind of like being on social media to me. There's not very much upside and almost unlimited downside, right?
Okay, that's a
Like,
good way to describe it.
there's just this huge risk, right? And no one's going to risk their permit or risk an effluent violation. And that's the way it should be.
Right.
That's why we have these things, right? So before we get into like unit, like process, conversations and things that are risky, we like to start with like, there's some really no risk, low risk things out there that we can just do. And quite honestly, most wastewater plant folks don't even know what their power bill is. They don't get it, right? It goes downtown or to city hall.
Sure.
So for them to even talk about it, right, it's kind of a new thing. But there's lots of facilities out there. There's lots of places where we have come in with things that are very, very sort of not related to the process or very limited process implications. For example, we have plant water systems. That's water that comes from the tail end of the plant, and you use it to hose things down, to have sprays across the top of tanks, that kind of stuff. And everyone considers that to be free water because it's just plant water that you're reusing, right? And what could the cost of that be? Well, you're sort of paying the electric utility to use that water because you have to pump it up and pressurize it, right? Before you can use it for sprays and things like that. And I've been through lots of plants where they're running plant water systems at 70 psi or 80 psi. And really, does it need to be that high of pressure, right? So
Mm,
maybe we just lower that pressure a little bit and save a
interesting.
little energy. We lower the amount of water we're spraying on our tanks 24/7, right? It's just like, if you have that mentality that it's just there and you can use it as much as you want, that's what you tend to do. So we just try to get people to think about it a little bit differently, right?
Right. That's
Um,
interesting.
and like there's another simple one, which is like lots of almost everything in a plant. There's 2 or 3 identical units, right, for redundancy. And I'll guarantee you that those 3 identical pumps or identical blowers are not identical. one of them was built on a Friday, one of them was installed on a Monday, right?
Right.
There'll be little
A little
differences. And
different.
so there are differences in efficiency. And if you know that, then you can favor the more efficient unit or maybe avoid the bad one. And you talk to operators, most of them know that. Most of them are like, oh yeah, that pump just doesn't do as much as the other ones, you know? And so you're like, well, why are we running it? You
Make
know,
that the
so
backup.
stuff like that. Yeah,
Yeah.
exactly. Yeah.
Yeah.
So very low risk things to start with. And you do that and you sort of start seeing the guys start seeing, hey, this is making a little bit of difference, right? If they can see that over the course of a month or something, then you're like, okay, this actually matters. What I do every day actually impacts the costs. And that's how you generate a little bit of confidence and some trust. And then we can have bigger conversations about bigger process changes that have a real impact.
So just going back to something you said before, which was interesting, where you said, typically these people in the plants aren't getting the bill, right? They're getting
Yeah.
someone else is getting the bill. But I feel like we hear more about this now. Is it because like costs are rising and it's becoming more on their radar? Like why is there more of a focus on this right now? Is it just the usage, like you said, where it's going up more than it has in the past? Or
Yeah, I think there's definitely been a push, um, or maybe a recognition on behalf of the electric utilities that they recognize that they have these big loads out
Mm.
there. And so when you go to talk to, and it's just like, I don't know, it's kind of funny. Like with wastewater, you're either in the club or you're not in the club.
Right.
And so when somebody from the electric utility shows up at the plant, they're not in the club, right? And so the plant people tend to like listen and smile. If the electrical people wants to go look at something in the plant, they will team them with an electrician
I see.
because it's electricity, right?
Right.
Uh, so, so, so I just think you're hearing more about it now because I think there is a recognition on behalf of the electric utilities that yes, there is a resource out there that they could be potentially engaging with, right? To lower some of their, to put some more energy conservation into that space, into the water and wastewater space. But I also think you hit the nail on the head. You combine, electricity rate growth with load growth with just the cost of compliance now with all the new, we were talking about, I think it was your wife, dealing with PFAS now, right?
Yes.
And
Yeah. She works
like
with PFAS. Yeah.
as we get to measure more, the better we get at measuring things, the more stuff we find to measure, right?
Yeah.
So you couple that on, the electric rates are going up. That's pushing water and sewer rates up, and everyone is so concerned about affordability,
Yeah.
rightfully so. So I think a lot of people in the water and wastewater industry are recognizing that one of the controllable costs is energy. You can't control the rate you're paying, but you can control how much you're using. And I
Hmm.
think that's what has, dawned on a lot of folks.
Yeah.
So he's becoming more aware. Like, there's, treatment plant operators, one of the industry mags, right? They always have a section on energy and energy efficiency, almost every issue now, So I think it's just becoming more of an awareness thing.
Yeah, and I think it's like one of those things where you get your credit card bill every month, and if it's the same amount, you pretty much pay it and you don't really pay
Yeah.
attention to it, right? But if it starts to get
Right, right.
significantly more, you're going to say, hey, what's going on here? You start to look into it a little bit and see what you can do. Layne, do you have an example of where an energy driven process change also maybe improved effluent quality or consistency? Any examples you can give us of something like that? Or
Well, I mean, in general, when we do efficiency work inside of a plant, um, it's really about optimization.
I
It's
see.
really about digging in and making sure that that process is doing what it was supposed to do. And you know how the world works. We fix something, we do a workaround because something broke, and then it just gets stuck in that position and we don't get back to it, right? So maybe there's things that have been sort of out of whack for a while and you just start to live that way, right? So one of the things is we kind of go through and just make sure is everything doing what it's actually supposed to be doing here. But there's a pretty good example of this happening around the country now, particularly in the Mississippi drainage. So there's this thing called the Gulf hypoxic zone, which is like this area of the Gulf of where the Mississippi dumps out, where oxygen is depleted because of too much nutrients, right, in the river. And so wastewater plants that discharge into the Mississippi watershed, which is half the country, um, are being asked to reduce their nitrogen and phosphorus loads in their effluent. So almost every plant converts ammonia to nitrate. Sorry, this is getting a little nerdy, but you can, if you turn, so let me simplify it. if you aerate 24 hours a day, you're going to burn off all the ammonia, which is good because ammonia is a poison downstream. So you need to get rid of that.
Okay.
And ammonia turns into nitrate, which is great. It's still nitrogen, it's still in the water. So that nitrogen is still there for downstream things to enjoy. If you turn your blowers off for a little bit, then you've got nitrate plus food, and another set of bugs will actually sort of break that apart. And then nitrogen actually goes out into the atmosphere.
Hmm.
So that actually gets rid of the nitrogen from the stream. Okay, that's how you reduce the nutrients. So that little trick of turning your blowers on and off does two things. One, it saves you a bunch of energy and costs. And two, it actually denitrifies the water so the nitrogen comes out of solution and goes up into the air. So effluent quality gets better, right? We're helping the downstream processes because there's not as much nitrogen in the water, and you're saving some energy at the same time. And that's
Interesting.
happening. There's folks like Grant Weaver's working on that. And there's several states, Kentucky, Missouri, several states have sort of sponsored that as a program within their states. And it can be done at really low costs. So it's one of those things where you can optimize and get part of the way there for this nutrient removal situation without spending a bunch of money, and along the way save a bunch of money on your energy bill.
Interesting stuff. I mean, I think that's why this water, wastewater, there's so many interesting topics going on right now. We talked about some of them already being the electricity demand. We talked about the data centers a little bit. And again, the data centers, from what I've read some stuff about it, some of these require like 1 to 5 million gallons of water per day, which is just crazy. But I guess it's mostly for cooling from what I
Yeah.
read, right? To
Yeah.
cool the data center. But again, when you're typing into these tools online, these AI tools, you don't really understand the back infrastructure piece of it with the servers and everything that they need for this and what kind of a taxing it puts on these
Yeah.
systems, right? And it's
Yep.
becoming a huge topic in project management world.
Yeah. I think, I don't work in data centers. Some of the people here do. I don't do much work in that space, but I know that every time we have like an industrial symbiosis conference or a get together, or we talk about sort of circular water economy, right? We are going to start focusing more on water as that's fit for the purpose. So do you need drinking water quality to do cooling water? Some maybe, but maybe not, right? Maybe there's other places we could use,
Hmm.
maybe there's other qualities of water that we could use for those purposes, right? So I think that's starting to happen. And obviously the hyperscalers, those guys are all interested in doing whatever they can because they know their footprint's huge
Right.
and they're trying to reduce it. So I think there's actually some pretty good, interesting things happening in that space now around how they're using water and then what kind of water they're using.
That's
Right.
interesting. Yeah, we'll have to do a whole separate episode and bring
Yeah.
in some people that are working in that space
Yeah.
because I know there's a lot going on there.
Yep.
So the last thing I wanted to ask you today, Layne, is, we talked a lot about energy today and, thinking about being efficient with it, right? With utilities, water, wastewater. When you work with these utilities or when you're working in the water, wastewater space, how do you go about kind of getting buy-in, right, from some of these improvements when you talk about leadership, operators, the community, all the people that might be involved in your projects? From your perspective, how do you do that? How do you approach that?
Yeah. It, like we kind of talked about it, it comes down to establishing some trust. I'm never going to ask somebody to do something that makes them put their permit at risk.
Right.
That's the first thing, right? So, and you kind of got to be in the club, right? You got to, like, you have to kind of prove your chops that
Right.
if you walk in, here's a tip. If you walk in and you have wastewater as two words, you're not in the club, right? Wastewater is one word. But how many times do you see that?
Right.
So it's just one of those simple things. And as soon as someone sees that, they're like, okay, this person doesn't know, they're not part of us, right? So that's one thing. The other thing, like with engineers, I mean, we're a conservative bunch. I mean, rightfully so, right? If you install a pump that's too big, you throttle it. That's fine. If you install a pump that's too small, you fire the engineer, right? Because you can't do anything about that.
Right.
So we are a conservative bunch, and so you know internally and within the engineering community, actually getting folks to care about energy. And I'll say, right away, I did this for 10 years and we never thought about it. And it was never part of the consideration. Energy was, not too cheap to meter, but pretty much didn't matter in the grand scheme of things.
Right.
And I think there's still folks out there that have that maybe that base thought. That's going away. It's becoming more and more of a thing now. So part of it is just awareness, like, hey guys, we can actually do something about this. And if we're buying new equipment anyway, how about spending a little bit extra money and get the best stuff we can? Or thinking through, we get big buckets of money and we have to design these plants for 20 years out.
Yep.
Because we know that's the last time we're going to get some money, right? But it has to operate a long time before we get to those 20-year loads. And sometimes those 20-year loads never even show up. So my focus with engineering is always, how is this going to work the day we open the plant? How is this going to work tomorrow at these really low loads? Can we turn everything down? Can we meet those low loads efficiently? That's what we need to focus more on. And then with leadership, I think my biggest thing when talking to like plant managers and the superintendents in charge of, like, if we're doing O&M program type of work,
Mm-hmm.
the manager or the superintendent, they have to allow the operators to make changes. They have to allow that to happen and be comfortable that they're going to take a baby step, watch it very carefully. If it's not going the right way, we'll step back. But they have to be allowed to make that baby step and not have big negative consequences coming down, right?
Interesting.
So it's all about change management. If you don't allow change, you're not really doing change management. You're just doing management. You already do that. So what's the point?
Yeah, no, that's interesting. And I think something that you said there is important. I think for civil engineering, just broadly, is that there's so many different subsects of quote unquote civil engineering, right?
Yeah, for sure.
And, this is the civil engineering podcast, but we could do a million different episodes on a million different topics. And to your point, you've got to know your discipline. You've got to know your technical background if you're going to be able to engage with people on that topic, right? Like the wastewater example that you gave, right? If you're a geotechnical engineer, and you're working on a project, you need the geotech to really be able to talk about the soils, and someone's going to know whether they know what they're talking about or not, right?
Right.
So I think that that's just a really good piece of advice just for, in general, when you're working in engineering, especially in civil engineering, is that you're going to get involved in probably one area. And if you really want to be able to talk the talk and engage people, get buy-in, right? You're going to need to be able to talk shop with them more or less, right?
Yep.
And they're going to know that by some of the things. And if you can't, you better bring someone who can, right?
Yeah. Yeah.
I mean, I think that's like project management 101. If you don't, you're not going to be able to talk, especially if you're presenting to a board or presenting to even the public, let's say, get the right people in the room with you.
Right.
All right. So Layne, what we're going to do here to wrap us up, our last thing we're going to do is what we call our civil engineering hot seat. So what I'm going to do is I'm just going to pepper you with a couple of very rapid fire career related questions, just as our last piece of today. In the AEC industry, skilled project managers are the backbone of success. EMI's AEC PM certification offers tailored training, ongoing support, and exclusive access to premium content that keeps your team sharp and effective. From foundational training to advanced leadership tools, set your team apart with certified growth. Learn more at aecpm.com. That's aecpm.com. The first one I'm going to ask you, Layne, is do you have any specific rituals or routines that you practice every day, whether it's a lunchtime or morning routine or just something that you've done over your career kind of consistently that's helped you in your career?
The only thing I make sure I do is I got to get outside every day, no matter where I'm at, get some fresh air, especially now that we spend all day staring at screens and talking on videos with each other.
Yeah, for sure. So getting out, getting in the environment. Okay, great.
Yep.
Has there been either a book or an author or a philosophy or framework or something in your career that you ran into and it kind of stuck with you and you've kind of leaned on it in your development?
I say there's two books. They're both old, relatively old. So I had to read The Goal in college.
Okay.
And that's about sort of manufacturing and bottlenecks, right? And it's also about management. I think it's in its like fourth printing now or some crazy thing, but it's funny when you're college, you don't realize those are the important books, but that turned out to be one of the important books. And the other one, there's a book called To Engineer is Human, which kind of talks about engineering failures and how all engineering designs and decisions are human decisions and
Yep.
how those failures sort of impact everything. And that book just kind of made me realize, like, these things that are sort of catastrophes or failures, there are people behind those, right? And it is just remind you that math's great, but at the end of the day, a bunch of things are human decisions.
Yeah.
So
No, those
anyway,
are that I've read that book, and then the goal, the one that you mentioned, the goal, also, like you said, it's a process book, process of ongoing improvement is the subtitle,
yeah,
but
yeah.
some good books there, so that's good stuff. All right, the next one is when you think back on your managers that you had in your career, and we're not asking you to name any names, but just think about some of your favorite managers. We're trying to understand, what do you think makes kind of really good managers and leaders in the civil engineering world?
Well, the best manager I had in engineering was I think he's my first manager probably. He's passed now. His name is Mo. I called him Mo. Everybody called him Mo. But so I was on the job site and he was the project manager. And so he would make trips to the job site, but I would call him, right, with all these questions. Hey, this is happening. And about 2 months into my career, he said, Layne, I love it when you call me with questions and problems. I wish you would also call me with suggested solutions. And he's like, we hired you because you're capable. So think a bit and you can come up with an answer just as easy as I can. Right. And that was just
Wow.
like, that was just his approach. Right. And that
Yeah.
just stuck with me. It was a really nice thing to say, like, all right, I do belong here. I can handle this. Right. They did hire me for a reason. So I'll try to come up with something. And if it's wrong, that's fine. But at least I have something to offer. Right.
Yeah.
So, and I think a lot of folks struggle with that. Like, I don't have anything to offer. No, you do.
Right.
You get the same education as the rest of us, so use it.
Yeah, that sounds like a great confidence builder, right?
It
For
was.
for a leader to be able to say that to someone. So that's
Yeah.
great. All right, last question that we have. We call this the civil engineering career elevator advice question. So if you got into an elevator with let's say an up and coming civil engineering professional, you only had about 30 seconds with him or her to give some career advice. Based on your career to date, what would you tell them in that short period of time?
I would say civil engineering is just hugely broad subject area, and see if you can find one or two things that make you happy, that you enjoy doing. A really good friend told me, if it's not fun, why are we doing it? So try to take that to heart. So find something that you can have fun with and that you enjoy and that you can dig into and become an expert. And that will give you marketable skills and it will open up doors to some really cool stuff later in your career.
Awesome. All right. Well, once again, Layne McWilliams. Layne is the principal consultant and treatment group lead at Parametrics. Layne, thank you so much for spending some time with us here on the Civil
You bet.
Engineering Podcast.
Yeah. Thank you, Anthony. Been fun.
I hope you enjoyed my conversation with Layne. Please consider subscribing to our channel here. We put out videos like this on a weekly basis to help civil engineers become better project managers and leaders. I hope to see you next week.